before we could start on stoichiometry, we have to discuss the concept of a mole. Now, this gives more people trouble than almost anything else in chemistry, is what a mole is. All it is a number. So I like to think of it as a chemist's dozen, right? Like you have a normal dozen, which is 12. A baker's dozen is 13. A chemist's dozen is 6.022 times 10 to the 23rd of something. So if I said I had a couple of dollars or a couple of markers, it means I have 2 markers. If I have a dozen eggs, well, that means I have 12 eggs. A baker's dozen of eggs would be 13 eggs. If I have a mole of eggs, then I have 6.022 times 10 to the 23rd eggs. If I have a mole of people, then I have that many people. A mole of atoms means I have that many atoms. A mole is just a number, and that's the number, Avogadro's number. Now, why do we care about this obscure number? It's a huge number, right? Well, atoms and molecules are really, really small, right? So it takes a lot of them before we could even begin to measure them. So with that in mind, let's think about what chemistry is and what we do with chemistry. Well, we, do experiments and we add this to that. Well, we need to know how much of how many atoms we're adding to something, right? But you can't measure atoms. You're not going to go and count individual atoms. So what we do, what do we use? Well, we measure stuff, and we use the SI system, right? So in the SI system, we deal with grams, especially in the laboratory. You like to, you're going to measure something out, like you want a gram of sodium. So you measure that out. But how many atoms are in that? Well, that's where the mole comes in handy, because it's used for conversion. Now, when we did dimensional analysis, we talked a lot about conversion ratios. For instance, 1 inch is 2.54 centimeters. And that can be used as a ratio in dimensional analysis. Likewise, we're going to use moles, the concept of a mole, to convert between grams and numbers of atoms. Because in chemistry, we're concerned about the atom, right? If you're going to burn something in O2, you'd like to know how many atoms of whatever are reacting with something else. And in order to do that, we use the mole. That's all it is. It's a way to convert. Now, if you look on your periodic table at carbon, you're going to see this number, 12.01. Now, you might have a different periodic table. It might be 12.011 or whatever. It's going to be right around this ballpark. What this number stands for right here is grams per mole. You could think of this as a conversion ratio. So if you have 12.01 grams of carbon, that's going to equal 1 mole of carbon. So that's what that number means. We're going to use that in stoichiometric equations with dimensional analysis to convert between grams and atoms. And the mole is the way that we go through that. So, for instance, I want to make sure that I add an equal amount of water atoms or water molecules and sodium atoms together. Well, it's weird because sodium weighs a lot more than water. So you can't just say, okay, let's think about lead. Lead is really heavy. If you have this much lead, it weighs as much as, this much water. So with chemistry, we're working with the atom, and we want to try to get the right number of atoms together, okay? But if each atom of lead weighs so much more, then you can't just put it on a scale and say, okay, I have the same weight, because the lead weighs so much more and you're not going to have the right number of atoms. So this whole fuss about the mole and Avogadro's number, it's a way to take a known weight, so I have my lead or sodium or whatever, I'm going to weigh that. And now I want to know how many atoms are in that. Well, we're going to use these conversion ratios and Avogadro's number in order to find out exactly how many atoms we have. And with examples, this should become more clear. But right now, I just want to introduce the concept of the mole, and in the next video, we're going to do some calculations involving moles.